Hello, my name's Bagas Pratama, and I'm from Marine Engineering Batch 24, and I'm here to participate as candidate of lecture assistants magnetic physics Batch 24 and 25 and 26. So I'm here to wanna teach of my friend. So would you like to introduce your name?
Yes, my full name is Gurmal Orman. You could call me Orman.
So okay, that's good. Okay, so we just solve for this problem. This is a mechanical physics, which is like particle dynamics for the material lessons.
Mhm.
And for first, in addition, we have to analyze what do we have for these questions. And then we put a where here. So give any information what we have. We have a first mass is 15 kilograms, and the second mass is 5 kilograms. And the incline or the angular motions, the symbol is theta. We have 37 degrees for both sin and cos.
Mhm.
As for frictions, mu, k, frictions kinetics is 0.4, and frictions, I'm sorry, it should be static first. And mu k or stands for the kinetics, so it's 0.2. Oh yeah, this is for the mu is dimensionless, which means there's no unit on it. So we have to analyze what do you have in this object. It will again start with the normal force. It will going up is an normal force, and uh the wy, which means have the mg cos theta, and wx is mg sin theta. And in here, we have probably, wait, I'll do it for the frictions. And here the frictions, because CC4A is like the staying of the smooth, so it's not have any acceleration. We assume that we're using mu s. It's static. The friction for static is the formula of the friction static is mu as times m, and this is for the rope is T1 and yeah, that's right, T1 and T2. And this for the mass is 50 kilo, and this 5 kilograms. So okay, we have to determine how do we get to find the tension. So basically, just like this, T minus sigma F equals 0. T is sigma F. The sigma F
Mhm.
is only of the W. And then T equals W, it's mean like M1
Yeah.
times G. So the M1 is 15 kilograms and gravitation is 10 mere
Okay.
second quadrat equals 1500 Newton. Okay, so we again to start finding force at A choice. Okay, so the block will move to the right. We shall begin with sigma F equals 0 because we are using the physics first Newton law and the second Newton law. But do you know what differences between them? I mean like the first law and the second law in Newton.
The difference between them is like acceleration. The first law doesn't have an acceleration. The second law has an acceleration, right? The first law is just like the law of inertia.
Okay, that's very good explanation. Thank you. Okay, first we have to find the I forgot. Wait. So the new normal force it should be like the same the sigma f like we do have I'm sorry and minus, we put this F cos, oh, God damn. We put in the W, so this will be F cos theta. I forgot this missing someone. It should be F cos theta. Then this F cos theta move to the right side, so it will be where my W minus F cos theta degrees. Okay, then it will be clear. So, and normal force minus, I mean like plus W minus friction static and minus T1 plus T1 I mean minus T2 plus T1 and plus M1G gravitation equals 0. Then the normal force we elaborate of this elaborate of each this equation or formula. So N is should be F cos theta plus WM2G because we are using this block. I think we assume this there's no any forces. Okay. Okay then M2G cos theta minus the mu k and this is just we just like distinguishes this. So we'll have only
Yeah.
we are using this combination. So remember the W equation is M2G cos theta minus F cos theta. Wait. Okay, I think that's all you want to. So this will be sin degrees
Mm.
theta. Okay, and plus M1G equals 0. So basically, this is all. We have to just remove this. So they basically, this all for the total forces. And the second is, because this is opposite directions, so it's still the same of the analyzing for this object, but just because this opposite direction, we put like reverse of this. So you just move to no, minus normal forces minus W minus, I think I have left, okay, it should be minus, not a plus. Yeah. Sigma, I mean the frictions, static, my plus T2 minus T1, but this is the same, plus M2G equals 0. So it's just left the carry off of this. So the N is like the same, and F cos theta W minus M2G cos theta minus mu as uh, M2G cos theta minus F sin theta plus minus M2G M1. Sorry, it should be M1. Yeah, so it's basically the same total forces. For C, it's different because we have to use this acceleration. So we obviously to use sigma F equals ma. Because there's two object in here, so
Yeah.
we have the total mass of this m1 plus m2 and the accelerations. Okay, we have to use this. Um, but this is still the same of the total forces. M1 plus M2 times A. The sigma is N plus W um, minus sigma forces minus friction kinetics. And yeah, because this is like we assume this things or this object is have acceleration, so we basically thinking these things will move. So the friction or the slope will be kinetics or moving. But the friction static and the friction kinetics, it's always the same for the formula. Okay, then kinetics and minus m1g equals m1. This is m2. M1 plus m2 and a. Okay, then um, so it's the same like this. We just put in u equals um m1 plus m2 times a accelerations. So d, it is basically the same like the b1, just because they are the opposite directions. So you just put the reverse or the minus. And once you should in times accelerations. So it's totally the same like n minus v w minus friction k minus or plus my m2 m1 g equals m1 plus m2 times acceleration. So this is all the total forces. So we have to the substitute of each this formula. So I actually like already finished for this. So let's take a look. This this answer actually so yeah, of course that this old formula or these equations will become the have this substitute. So eventually we have 0.8 f plus 30 minus 16 because we have to times or multiple by this one and this one. And we found 16 plus 0.24 f minus 150. So actually we have the first A answer is 130 Newton
Yeah.
and B is 185 Newton and C is 139 Newton and D is 164 Newton. So that's basically we have to find the F. So how do you find the T? I think that's basically the same. We found T is 100, 150 Newton because we don't actually have a exactly number. How do we get this? And there's
Yeah.
no like
Uh,
there's no angular motion.
Substitute.
Yeah.
Uh-huh.
So we just assume that the tension is just like this. So that's all from these questions. So so far, do you have any questions?
Yeah, I have one question. Why do we put sigma before F? Like before F, where you put like sigma, you're always like, writing sigma before F. What's the purpose of this? Like,
So thank you for the question. You mean like the sigma F equals 0 because the sigma is actually the total of the force, like I
ah,
said before.
okay.
This
Thank you.
this
Yeah.
is okay, but yeah, this is all is yeah, this is all is are the force
Total force.
that's given an impact or given an impact for the this object. So that's why I put a sigma. So
Yeah.
do you have
Okay.
another
Okay.
questions? I think that's enough because we have limited.
But if the box like moving in on the opposite direction, right? Upwards.
Yeah,
Then we would summarize like we would sum those like t second and the force the friction force together, right?
yeah. So you have
Uh,
so your question is how do you find the is there any differences between like going up, down, and going up, upward with the frictions or
yeah, this is my question. Like going upwards, but in this case, like going upwards is a little bit difficult. Is like easier than going downwards. Downwards, you have to put a lot of so much like force because this like pulley. There's a pulley, right? This luggage. This I mean, it just like pulls this down, like right. Pulls this upwards, like this. You know, this M2 mass, right? It's going upwards because this M1 mass pulling down this uh, luggage, right? Basically.
so yeah. Um,
Yeah, well, it's not a question, it's just like statement. It's just not a question. Yeah. Uh-huh.
oh, okay. So
Mhm.
so far, do you really understand for these materials?
Yes, I did. Thank you. Everything is clear.
Okay, I think it's all clear for this problem. Thank you for your time, Norman.
Thank you, Badis. Thank you. Thank you for explaining. Thank you for your time as well.